So good morning boys. On the previous turn when we have started the topic matrices, we have discussed about the meaning of matrices, order of matrices. Then I have told you about how to write a general matrix and then about the types of matrices like row matrix, column matrix, rectangular matrix, square matrix, diagonal matrix, then unit or identity matrix, zero matrix or null matrix, transpose of a matrix, and then I have told you about equality of matrices, that when any two matrices are equal, and the operations, and then we have discussed already about addition and subtraction of matrices and the condition when they are possible, and then I have explained you about multiplication of matrix by scalar, and also about additive identity and additive inverse in case of matrices, and then I have told you how to solve the matrix equation. And after that I have given you the assignment also, which you have done in a very successful manner. Okay, now in continuation with it, today I am going to start with the multiplication of matrices, and this is very important as per the board examination point of view, because question based on this will definitely come in the finals. Okay, so let us start with multiplication of matrices. So over here you have to understand, just keep this thing in your mind, that two matrices, suppose A and B are the two matrices, they can be multiplied only and only if number of columns of the first matrix is equal to number of rows of the second matrix. Just keep this thing in your mind, that number of columns of the first matrix is equal to number of rows of the second matrix. Like for example, I have written the first matrix of order m by n, matrix A as m by n, and second matrix B of order p by q. So what is m by n? Row by column. That means column in the first matrix is what? N, and order of matrix B is p by q. What is p over here? P are the number of rows. So over here I have written if n is equal to p, that means number of columns of the first matrix is equal to number of rows of the second matrix, that is p. Then only product is possible, otherwise you can write that product is not possible. Now if number of columns of the first matrix and number is equal to number of rows of the second matrix, that is product is possible, then in that case the resulting matrix will be containing number of rows equal to m, number of rows equal to m, and what was m in our case? M was the number of rows of the first matrix, number of rows of the first matrix. Okay, and what was q? Q was the number of columns of the second matrix. So resulting matrix will be containing number of rows equal to m and number of columns equal to q. That means it will contain number of rows equal to the first matrix and number of columns equal to the second matrix. That means if n is equal to p, that means number of columns of the first matrix is equal to number of rows of the second matrix, then the resulting matrix will be of order m by q. Means I have written over here the resulting matrix as C, and C is of order m by q, means it will have the same number of rows as rows of the first matrix, and it will have the same number of columns equal to the column of the second matrix. Okay, so I hope that you have understood m by q. What is m by q? M by q is over here that it is having the order equal to number of rows of the first matrix and number of columns of the second matrix. Now how to find the resulting matrix C? So I have written over here like aijth element of the resulting matrix C. I have taken any general element of resulting. Suppose you have multiplied and you have got the matrix. So I have written over here that aijth element of resulting matrix C. But over here aijth element is different from that which you have learnt earlier in the formation. Like what was Aij earlier representing Aij was element of the ith row and jth column in the beginning when I told you how to frame the general matrix. Okay, but over here when we talk in terms of multiplication, what is meant by Aijth element of the resulting matrix means the element obtained on multiplying the ith row of the first matrix multiplied by jth column of the second matrix. Okay, ith row of the first matrix multiplied by jth column of the second matrix. Okay, so over here you have to just remember matrix multiplication will be very easy if we form a general matrix of the resulting order. Okay, when it's any general element is Aij and it can be again obtained as ith row of the first matrix multiplied by jth column of the second matrix. Okay, let us understand this thing in a much better way with few examples. Like question number 1 is, if A is equal to 1 minus 2 1 2 1 3 and matrix B is 2 1 3 2 1 1. So write down the product matrix AB, and second, would it be possible to form the product matrix BA? If so, compute BA. If not, give reason why is it not possible. So for proceeding with the sum, okay, I have written to find the product AB. First of all, let us write their orders. Okay, matrix A was of order 2 by 3 because it is containing 2 rows and 3 columns. Okay, 2 horizontal lines representing 2 rows and 3 vertical lines means containing 3 columns. So 2 by 3 order. And the second matrix is of order 3 by 2. 3 by 2. So over here, because 3 rows and 2 columns. So over here you can see that number of columns of the first matrix is 3. Okay, because order is 2 by 3. And number of rows in the second matrix is 3 because order is 3 by 2. So in this case, both number of columns of the first matrix is equal to number of rows of the second matrix. In both the cases 3 and 3. That means product is possible. Okay, as per the rule that number of the columns of the first matrix should be equal to number of rows of the second matrix for matrix multiplication. So over here we have got in both 3 and 3. Okay, that is product is possible. Now I told you previously that just to form a for finding the resulting matrix, it will be quite easy if you form a general matrix, and general matrix in the resulting matrix in this case will be containing the element of order 2 by 2. Okay, I have written over here with a blank rectangular bracket. Okay, and order will be containing the number of columns or number of rows of the first matrix and number of columns of the second matrix, that is 2 by 2. So let us form a general matrix of order 2 by 2. You already know how to form. So I have written over here general matrix of order 2 by 2 as A11, A12, A21, A22. Like for example over here A11, how can we get the first element A11? Multiplying the first row of the first matrix by multiplying the first column of the second matrix. Okay, so we will get the first element A11 and we will proceed for the remaining elements also. And when we will proceed over here, okay, over here A11 first row, okay, first row multiplied by first column, okay, multiplied by first column. So what was first row? 1 minus 2 and 1, 1 minus 2 and 1, and multiplied by first column of the second matrix, that is first column of the second matrix, 2, 3 and 1. When we will multiply, then we will get the result as 1 into 2 plus minus 2 into 3 plus 1 into 1, and in this way we got the first result in the first element A11. In the similar manner A12, A12 means first row of the first matrix, okay, first row of the first matrix multiplied by second column of the second matrix A12. Okay, so when we will multiply, we will get 1 into 1, okay, plus minus 2 into 2 and plus 1 into 1. We have got the second term A12. And in the similar manner, just to find the value of the third element A21, what we can do, we can multiply the second row of the first matrix multiplied by the first column of the second matrix. Okay, so we will get 1 into 2 into 2, okay, plus 1 into 3 plus 3 into 1. Okay, so and for getting the fourth element A22, that is, we will multiply the second row of the first matrix multiplied by second column of the second matrix. Okay, second row of the first matrix multiplied by second column of the second matrix, we will get this element. Okay, 2 into 1 plus 1 into 2, okay, plus 3 into 1. So we have got this result. Okay, and we got the final product AB as, after simplifying, AB is equal to minus 3, minus 2, 10 and 7, and this is the answer for the product of the two matrices A and B. Okay, AB. Now for finding the product BA, what you will do, you will write the matrices in the same manner like BA. Matrix B should be written first with a product sign in between, and then afterwards I will write matrix A. And in this case, if you see, again I will proceed in the same manner. I will write their orders, okay, first. So what is the order of the first matrix? 3 by 2 over here. And what is the order of second matrix? That is A, 2 by 3. So in this case also, number of columns of the first matrix is 2. Number of rows of the second matrix is also 2. That means product is possible. Number of columns is equal to of the first matrix is equal to number of rows of the second matrix. That means product is possible. And what is the order of the resulting matrix? 3 by 3. It will contain the number of rows of the first matrix and number of columns of the second matrix. Now how to find? Again I will proceed just like in the previous case I have done. Number of columns, okay, is 2, number of rows is equal to 2 of the second matrix, so product is possible. And now I have proceeded in the previous manner. I have written a general matrix of order 3 by 3 because the order of the resulting matrix is 3 by 3. So when I will write a general matrix, I will get A11, A12, A13, A21, A22, A23, A31, A32, A33. I have written a general matrix of order 3 by 3, which is the order of the resulting matrix. So like how can we get all these elements? Like for example, I have taken a general element A23 from this matrix. A23 can be obtained by multiplying second row of the first matrix multiplied by the third column of the second matrix. So in this manner, I have written the elements like A11. A11 can be obtained by multiplying the first row of the first matrix, okay, that is 2 and 1 multiplied by 1 and 2, A11. This is the first element, okay, which we have got. Similarly, this is the value of A11. Then we will get A12. A12 means first row multiplied by second column. First row of the first matrix multiplied by second column of the second matrix. So we will get the value of A12. Then A13 means the first row of the first matrix, that is 2 and 1 multiplied by the third column of the second matrix, okay, that is 1 and 3. So we will get the third element. Similarly, A21. A21 means second row of the first matrix, that is 3 and 2 multiplied by the first column of the second matrix, A21. Okay, so first column of the second matrix, we will get the value of this element. Similarly, A 2 2, second row of the first matrix multiplied by second column of the second matrix. Okay, so we will get this value. Similarly, A 2 3 means second row of the first matrix multiplied by third column of the second matrix, that is 3 2 multiplied by 1 and 3, you will get this element. Then coming to this element A31. How can we get? A31 can be obtained by multiplying the third row of the first matrix multiplied by first column of the second matrix. Okay, and similarly you will get the values of the remaining elements also. Similarly we will get the values of the remaining elements, that is A32 and A33 also. And finally you have seen that resulting matrix BA you will get as 4 minus 3 5, 7 minus 4 9, 3 minus 1 and 4 of order 3 by 3. So what have you noticed over here? That order of this matrix is 3 by 3. That is BA is 3 by 3. And what is the order of the matrix AB which we have got in the beginning? It was of order 2 by 2. So you have seen that the orders of AB and BA are different and the matrices are also different. That means from the above result we can conclude that the product of matrices is not commutative. Not commutative. A into B is not equal to B into A. In matrix multiplication it is not commutative, but it is commutative in over the case of addition. Okay, in case of addition, matrix addition is commutative but multiplication is not commutative. Okay, but in case of matrix addition it was associative. Okay, it was in case of addition it was associative, and in this case also, in case of multiplication also it is associative. That is, if you find the product of any two matrices A and B, then multiply that product by the third matrix C, and if you find the product of B and C and then you multiply it by the product of A, then both the results will be same. That means product of the matrices is associative. Okay, then one more property, if AB is equal to AC, then you can't cancel A and C directly. Okay, it is not necessary that B is equal to C, where B and C are the matrices. And now if AB is equal to 0, what are A and B over here? A and B are any two matrices, and 0 over here representing null matrix. 0 over here is representing null matrix. So then it is not necessary that A is equal to 0 or B is equal to 0. We can't apply the zero product rule over here, that if the product of any two matrices is coming equal to null matrix, then zero product rule is not applicable over here. Then coming to one more property, if A is equal to 0 means any matrix is equal to null matrix, B is equal to 0 means second matrix is also null matrix. Then if both the matrices are equal to null matrix, then we can say that the product AB will be also a null matrix. BA or AB both will be also a null matrix. But the condition for this is that both the matrices are also equal to null matrix. Okay. Now, coming to the sixth property, that in matrices, okay, especially in case of multiplication, it is distributive law is applicable over the case of addition and subtraction both. That is, if A, B, C are the three matrices, then A into B plus C is equal to AB plus AC, or A plus B into C is equal to AC plus BC. Similarly, A into B minus C is equal to AB minus AC, or A minus B into C is equal to AC minus BC. Means distributive law is applicable in both addition and subtraction. Okay, so you have to remember about these properties, that in case of matrix multiplication these properties are followed. That it is not following the commutative law. In matrix multiplication commutative law is not followed, but associative law and distributive law both are followed. Okay, now let us discuss one more example, that is question number 2. which I have taken. Let M be any matrix, okay, multiplied by a square matrix, okay, 1 1 0 2, and the resulting matrix is 1 and 2, where M is a matrix. State the order of matrix M and find the matrix M. How can you find the order of matrix M? Because it is already clear that you are multiplying matrix M by another matrix which is already known as 1 1 0 2, and because you are getting the resulting matrix 1 and 2, that means when you are already getting the resulting matrix, that means the product of the first two matrices is possible. Okay, suppose the order of the first matrix M is M by N, and the order of the second matrix I have already written as 2 by 2. That means N should be equal to 2 because product is already possible. We are already getting the resulting matrix, so product is already possible. That means N is equal to 2. That means number of columns of the first matrix is equal to number of rows of the second matrix, and it is must. Why? Because we are already getting the resulting matrix. And now because the resulting matrix contains the same order, means it will have the number of rows of the first matrix and number of columns of the second matrix. It implies that M into 2 is equal to 1 into 2. So from here you will get the value of M as 1. So what was the order of matrix M? M by N. That means order is 1 by 2. Now let us take matrix M. Let us write in the general manner A11 and A12 of order 1 by 2, or in place of these two elements A11 and A12, I have taken A and B as the elements of matrix M. So I have written AB of order 1 by 2 multiplied by the given matrix 1 1 0 2, and the resulting matrix is already 1 and 2. Okay, so I have done the multiplication in the same manner. First row, first column, A into 1 plus B into 0, and first row in the second column, A into 1 plus B into 2, and on the right hand side resulting matrix is already given, and because equal to sign is there, that means the two matrices are equal. So let us equate the corresponding elements. Okay, let us equate the corresponding elements. A is already 1 and A plus 2B is equal to 2. We will substitute the value of A. Okay, we will substitute the value of A as 1, so we will get the value of B as half. So resulting matrix M is containing the two elements A and B, 1 and half, and don't forget to write the order 1 by 2. Okay, let us discuss. I hope that it is clear. Now let us discuss about one more case I have taken. If matrix A is 1 upon 4, 3 by 4, X and Y, find X and Y if A square is equal to I, where I is the identity matrix. Okay, so I told you A square means what? The product of A into A, which is written, I have written the form of matrices. Okay, in the rectangular bracket, matrix A multiplied by matrix A is equal to I. Okay, so I have written their matrices also. Okay, what, like 1 upon 4, 3 upon 4, X and Y multiplied by the same, and you are getting the resulting matrix as a identity matrix. So I have over here encircled 2 and 2. Number of columns of the first matrix, that is 2, is equal to number of rows of the second matrix, that is 2. That means product is possible. Okay, and then I have written the order of the resulting matrix as 2 by 2, and because it is identity matrix, and I have already taught you that what is identity matrix. It is a diagonal matrix in which all the principal diagonal elements are 1 and rest of the elements are 0. So identity matrix of order 2 is 0 0 1. Like identity matrix of order 3 by 3 was what? 1 0 0 0 1 0 0 0 1. So but over here identity matrix of order 2 by 2 will be 1 0 0 1. And then I have multiplied as per the previous rule. Over here I have not written the general matrix but directly multiplied, because I know by this time when you will do the practice you will be comfortable. First row by first column. Okay, first row by first column you will get the first element. Okay, first row by second column. First row by second column. Okay, you will get the second element. Then coming to second row, first column, second row, first column, you will get the third element, and second row, second column, okay, second row, second column, you will get the fourth element. And then right hand side is already written in the form of identity matrix. So when you will equate, because the equal to sign is there in between the terms, so equating corresponding elements, what you will get, 1 upon 16, like I have equated the first element, 1 upon 16 plus 3x upon 4 equals to 1. Okay, the first element, I have got the value of x as 5 by 4. On equating, I have got the value of x as 5 by 4. And now I have equated the second element, that is 3 upon 16 plus 3y upon 4 equal to 0. When I have done this, I have got the value of y as minus 1 upon 4. Okay. So in this way, you can proceed. Now let us take one more example just to make your concepts more clear. If a is equal to 2 to ab, find a and b where a square is equal to 0. And over here I have mentioned where 0 is representing a null matrix. But sometimes in the question it is not given, or in the question paper also you will not get it is written as null matrix. But you should know that 0 represents null matrix. So I have written over here that because a square is equal to 0, it was already given. So I have written a square in the form of the product of matrices A and A. And then I have proceeded in the similar manner. I have written matrix A 2 times and on the right hand side, and then I have written their orders. And I have observed that number of columns of the first matrix is 2, number of rows of the second matrix is also 2. That means product is possible. And the resulting matrix will be of order 2 by 2. Okay. So, and what is the resulting matrix? A null matrix. So I have written a null matrix of order 2 by 2 in which all the elements are 0. Then I have multiplied the first row by first column, that is 2, 2 and 2a. So when I will multiply, I will get the first element in the similar manner, first row, second column. I have multiplied, I have got the second element, then second row, first column. Okay, I will get the third element, and then second row, second column, I will get the fourth element. And right hand side is already 0. So equating corresponding elements, because these two matrices are equal, so I have equated the corresponding elements like 4 plus 2a equal to 0. I have got the value of a as 4 plus 2a is equal to 0. I have got the value of a as minus 2. Okay, a as minus 2, and 4 plus 2b equal to 0. I have got the value of b as minus 2. Okay, so I hope that you have understood everything clearly. Okay, in case if you have faced any difficulty, we will discuss in the next session. But I have given you the assignment also based on this. Okay, and simply 10 questions I have given you. I am just reading out the questions so that there should be clarity. If question number 1 is, if a is equal to 2x, 0 minus half, and b is equal to 1, 4, 0 minus 1, you have to find the value of x. If AB is equal to BA, that is product AB is equal to BA. Then question number 2 is, if x is equal to matrix 4, 1, minus 1, 2, show that 6x minus x square is equal to 9i, where I is the identity matrix. Okay. Question number 3, find x and y if 3 minus 2 minus 1, 4 multiplied by the second matrix 2x and 1 plus 2 into minus 4 and 5, this is the scalar product, is equal to 4 into 2 and y. You have to find the value of x and y in this case. Then question number 4, matrix 8 minus 2, 1, 4 multiplied by x is equal to 12 and 2. Write down the order of matrix x and the matrix x. I have already explained you this as a second example. Okay, you can just follow that. Question number 5 is, if matrix A is ABCD and I is 1 0 0 1. Okay, then show that A square minus A plus D into A is equal to BC minus AD into I. Like over here, I have written A plus D. So A plus D, consider it as a what? Scalar. Okay. And like on the right hand side, BC minus AD. BC minus AD is just like a scalar. You are multiplying this scalar by the identity matrix R. And you have to proceed further. Okay. Question number 6 is A is equal to 3x 0 1, B is equal to 9 minus 16 0 and minus y. You have to find x and y, and what is the condition given? That A square is equal to B. Then question number 7 I have written, okay, and you have to find the value of x, y and z over here. Solve means you have to find the value of x, y and z over here. Question number 8 also in the similar manner, you have to find the value of x and y. Okay, I have already written the matrix equation. Then question number 9 also, okay, A is 1 minus 1 2 and minus 1, B is A 1 B minus 1, and A plus B whole square is equal to A square plus B square. This is the given condition. You have to find the value of A and B. Means you have to apply this condition, A plus B whole square is equal to A square plus B square. You have to find the value of A and B. Then question number 10 is, this is the last question. If one matrix is given as 2 minus 1 1 0 minus 3 4 multiplied by matrix A, and it gives the result on the right hand side as minus 1 matrix containing the elements minus 1 minus 8 minus 10 1 minus 2 minus 5 9 22 15. Find the matrix A. Okay, these are 10 simple sums which you will try, and I hope that you will be able to do them. Okay, so, and we will discuss the difficulties on the next session. That's all, boys. Thank you very much.